we've basically got the structure up now, and we have got all the scaffolding up as well, so we can access the outside of the building and then also move through the building as well internally from outside through the scaffolding. Our next step is roughing in all the electrical, all the plumbing, all the systems that are going to be in the wall, and then start insulating the walls as well, which brings me to the point then of the actual wall system that we're using for this. What is happening is we're actually going to be insulating the walls to R4, which is almost double the Australian standards, and then we're also going to be making the building airtight. So in the coming weeks, we're going to be basically trying to get all those elements into that wall. Now the wall's approximately 90, 110 mil thick. So from the outside, we've got the cladding, then we have an air gap in there, air cavity, and then we have the airtight barrier, or one of the airtight barriers, which is the external one, which is a material called Proclaimer. So normally there's building wrap on normal buildings, but this is a building wrap, which is a membrane that's breathable in one direction for vapor, but it's airtight. So it's an interesting sort of product where it releases and eliminates condensation within the wall cavity. So with that, we're also taping every part of that up so it's actually airtight. And I am looking forward to it, but I'm also not looking forward to it because it's very, very detail oriented. What then the next stage inside that is one of the insulation elements, which is a product called Aerogel. Now this product comes in the 10 mil thick pad, and the equivalent of that is about 45 mil of insulation, standard insulation pads. So the reason we're using that, it is a more expensive product, but because this house is so small, to get the R value rating of the wall, we'd probably have to build a 140 mil wall. By using this product, we're putting 2 layers of it in there, which is equivalent to 90 mil of insulation. So we're actually gaining 90 mil of required space effectively. So what that then means is we can reduce the thickness of that wall. Now, in a normal house, it won't make that much difference if we made 150 mil, 160 mil walls. But here, 90 mil on each side, that's 180 mil, approximately 200 mil, that's taken out of floor space, which is approximately that much. Every little bit adds up in this building, thus we're using this product. After that product, it then gets to the framing lining, and then in that framing lining, which is a standard 90 mil wall, we then have 90 mil insulation batts in there. Then just before the plaster, we've got a product called phase change material. Now this phase change material is a product of paraffin wax and various sort of products in there that actually have as a melting point, and you can get different melting points in this product at 25 degrees or 23 degrees. The one we're using is 23 degrees. What that means is this material, phase change material, will melt at 23 degrees, and when it's melting, it either absorbs heat if it's going from a solid to a liquid, and when it's solidifying, when it's going from liquid back to the solid, it releases the heat. So what it's trying to do is pull back the temperature back to that 23 equilibrium for it. So we're trying to get a constant temperature year-round of approximately 23 degrees in the house the whole time. In summer, that'll be fantastic. When it's a 30-degree day, it's 23 degrees inside, and in winter, it's nice and warm in there as well. So effectively, that's adding thermal mass to the building. So it works like brickwork. So if you have a brick house, it retains the heat, or concrete floors, it retains that heat, and it's got that thermal mass that it gathers during the day, and then it releases at night. So this product works the same way. The advantage of this product is it actually performs a lot better than bricks and so on, because if you have 4 or 5 consistent days, hot days, the bricks stop cycling through and cooling down. They don't have enough time to recover, whereas this product can change from liquid to a solid 5 times a day or 10 times a day. It doesn't matter, it's just going from solid to liquid. When it's becoming liquid, it's absorbing the heat. When it's going back to solid, it's releasing the heat. So it's a fantastic little product. It's basically like giant bits of bubble wrap. I've got some photos that you'll see on there that basically goes in after the insulation and before the plaster work. There's one more element that's between the plaster and this phase change material. It's the internal airtight barrier, which is another Proclaimer product, but it's designed for the internal walls. Again, between the external and the internal air tightness barriers, it's working together, trying to make the building airtight, but also letting the vapour and the building to breathe as far as condensation, lack of condensation build up in the walls. So there's quite a few elements in there. Again, with this whole project, we're looking at every element of it. So with the paints and so on that are going as part of this wall system, the external stain and the internal paints, zero VOC products that we're using in there. Unfortunately, in this country, I've struggled to get zero VOC sealants and glues and so on. They are available overseas. There isn't a distributor here, and unfortunately, I would have had to import a lot more than what I needed to make sure I've got adequate supply. Couldn't do it with a distributor. It's not available over the counter here, but it is a product that is going to be in demand in the future. But again, it's it's supply and demand on these things at the moment. So a lot of information there. Have a look at the project diary and the build section where we break every element down, and we go into detail for each one of these sort of products in the building system. One of the exciting things while all the roughing and so on's been happening, the hot tub's gone in. And it's quite exciting because that was one of the elements that I wanted in there right from the start, even before we started the project. And it was one of the things that's always been part of the scope of the project, and that is part of the lifestyle aspect of this build, and a space that makes you want to stay in the house and enjoy it, whether it's summer or winter. In summer, you can use it as a plunge pool. In winter, you've got this fantastic hot tub, so even if it's raining, you're sitting in there. They're having the snow. So, if you can use it in temperatures like that outdoors, it'll be fantastic to use it up there. And, in the evenings, at night, it'll be fantastic. Part of the assembly of this hot tub and the reason why it's going in at this time is basically getting it up there at the moment while the scaffolding's up. Because the base of it's in one piece, so it's a 1.4 diameter base, but all the staves in there are flat packed. So it's effectively a flat pack, but it's easier to go in at this stage. And then it's assembled while we've got it up on that roof deck. Otherwise, we physically wouldn't have been able to crane it in because there's horizontal beams running through the top of that deck. So we couldn't even drop that in. Otherwise, it would have to be dropped in 3 weeks ago, when we put the top of the roof deck in and the roofing and so on there. So we were able to then schedule it in slightly later in the build, but we wanted to get it up there as soon as possible as well. And it will really increase the use of that airspace up there, that exposed space in the top there, year round. And it'll really draw people to that area as well to utilise. So it smells fantastic. The cedar just smells great. And when it fills with water again, it'll release all those aromas as well in there. So there's this beautiful aromatic scent up there while we're working at the moment. And I can't wait for it to be filled up and being at a point that I can use it. Over this sort of period, we've got delivery of the off the plaster as well. So that's an exciting part now that we've insulated the walls, got the airtight barriers in there. We now have to get the plaster up. So I've been struggling a little bit with getting a plastering contractor in to actually install the plaster, because it's quite a sort of fiddly job as well, because those airtight barriers that are in there, when you're installing plaster, normally if you miss the stud, you can just move along and it'll get patched up. But on this job, we have to mark out where every stud is, because if we miss the stud, it'll pierce the face change material, it'll punch a hole in the airtight barrier as well. And all that work and time that we've spent being very pedantic about making sure that they're all right will have gone to waste. So it's going to be a slightly slower process of actually placing the plaster in there and fitting all that off. The next bit we're going to be waiting on is the glass to get the house to that lock-up stage as well. And that's part of getting it airtight as well. So we've got the windows in on the back, but it's this east facade now that we've got to get in there. The solar panels are also being installed at the moment, or the first sort of stage of it. All the ones on the top of the building, the vertical panels that are going on the north side have sort of been held up a little bit because we had to get an amended planning permit. One of the neighbours has objected to it, and we've got to go through that process and justify why it's going to be there. Funnily enough, he's on the opposite side of the building, but these are the things that sort of happen. But we're going through that process at the moment, and I'm sure that's going to be resolved. But we're working on the top solar panels. It's quite interesting with the solar panels as well on the top there, because we're using micro inverters, which mean each panel has an inverter on it, so they can actually generate power individually. They don't all need to be part of one circuit. We can have them on different planes, so we're optimizing production, but also the aesthetic side from underneath. I didn't want that roof deck feeling enclosed, so I designed the solar panel array so there's openings between them, and then also when you're standing underneath, there's a couple that are louvered up, so that way you've got this feeling of air and space while you're up there as well, so it's not sort of encroaching on you while you're under them.